Thank you. Welcome to the webinar, How Machine Learning Can Supercharge Pricing Analytics. Thank you for joining us today. We have a lot to cover in the next 30 minutes, so let's get started. First, let me introduce the speakers for today's webinar and briefly outline our agenda. I'm George Ravitch, Chief Marketing Officer for Earnix. I'll be your host for today. In a moment, you'll hear from Lucy Kanitz, Earnix Product Manager, who has been leading the development of our machine learning capabilities. She will provide background on our development and some of the use cases we have been applying our technology to. After Lucy, Yaron Nefesh, Earnix Research Team Leader, will give a short demo of machine learning capabilities in the Earnix software, and he will show how users are able to build better models to improve business metrics. He'll demonstrate how to use machine learning to gain insights that are not possible without using this technology. Next, I'd want to put the entire discussion of machine learning into context. I'm showing some industry research that Earnix commissioned last year. Among the insurance executives around the world we surveyed, 54% said they are currently using machine learning in predictive modeling projects. And the research showed that it was being adopted by companies of all sizes, although slightly more among larger firms. These organizations are seeing measurable benefits from their early use of machine learning. Our survey shows that greater analytical accuracy is by far the number one benefit that these users are realizing. So this was 2017, and every indication is that these trends are accelerating. Next, I'd like to introduce our first speaker, Lucy Kanitz, Earnix Product Manager, who has been managing the development of our machine learning capabilities. Lucy, go ahead.
Thank you, George. So nowadays, everyone is talking about how machine learning is the future of analytics. But to what extent is this applicable to financial industry? In the next half an hour, we'll see that machine learning is not just a buzzword, that there are real use cases for banks and insurance to use machine learning, and that with Earnix, you can deploy machine learning and use it into your pricing and marketing techniques to get better results in shorter time. So what are the main machine learning use cases? Of course, there are many. But our research team identified the following extremely beneficial use cases for banks and insurance when we talk about machine learning. First is reverse engineering of competitor price placements. This is the use case that became very important because more and more customers use price comparison websites before they purchase financial products. So it is important that your product is presented in the right way comparing to your competitors. Say you're selling an auto insurance policy and customer goes to price comparison website. If your price is too high comparing to competitors and you're not in the 3 cheapest offers, you have a smaller chance to actually get customers to your website and sell your policy. So later on, Yaron will talk more about this use case, and he will explain why machine learning models can help with this ranking problem and why the classical statistical methods and models are not good enough in this case. The second case is the next best offer action personalization. So with all the new data that is around, like telematics, the old algorithms are just not capable to process such huge amounts of data, whereas machine learning algorithms that are tree-based can in a matter of seconds deliver extremely important insights about customer behavior that can later be used for pricing and marketing. The third case is the customer behavior analytics. Aside from telematics, there's also a lot of data about how customers shop there. So data from social networks and other based behavior data. And tree algorithms work best with such types of data. This is sparse data with a lot of textual inputs, and linear and other models, the classical ones, just don't know how to deal with it and how to get insights from it. when machine learning algorithms are built to work with such types of data. So it doesn't matter where you are in your analytical journey, you can benefit from Earnix machine learning. At the beginner level, Earnix introduces you to creating machine learning models inside the software. You can build your first machine learning models with us. You can explore them. You can gain important insights, all inside the software itself. If you're at intermediate level and you already use machine learning and you have the models that you built externally using R or Python, Earnix allows you to import existing models and use them with your pricing strategy. At advanced level, you can both build machine learning models inside Earnix, import your in-home models into our solution, all together to blend them with the classical statistical models to deliver the base pricing for your product. So, what Earnix offers for now? We have an extensive library of classic statistical algorithms like generalized linear modeling. We also offer machine learning algorithms that our research team identified to be the best fit for financial industry. Algorithms like gradient boosting machine, random forest, and XGBoost. And at the same time, we partner with proprietary machine learning libraries like DataRobot, all in all to deliver enterprise-grade machine learning environment that helps you to build your models, analyze them, and most importantly, deploy them in a matter of minutes into your production. Because it is easy now to study machine learning algorithms in your lab, but we found that many of our customers priorly experienced challenges in deploying these pricing strategies to market. With Earnix, it's just a matter of couple clicks. So with all these new analytical capabilities, like machine learning, artificial intelligence, and big data, that deliver such great insights about customers, do we really need the classic statistical models? Well, you cannot toss out years of proven GLM models just because machine learning is cool. We know that machine learning models are strong with working with big data. They're good with working with sparse data, with a lot of textual and nominal inputs. But at the same time, they have their weaknesses. One of the main weaknesses of machine learning models is that they're not very good when we look at prediction versus inference dilemma. They know to predict and give the great prediction of your situation if nothing changed comparing to the insight you got from your data. But in financial industries, we do pricing. And when you change the price, the situation changes. And classical linear models know to adapt to this change, whereas machine learning models don't. So we want to combine. And because we want to combine, Earnix introduces hybrid modeling. Hybrid modeling is a unique to Earnix technique that lets you use machine learning algorithms blended with classical statistical models so that you can, on one hand, use the best machine learning techniques such as gradient boosting machine, but at the same time, keep the right monotonic continuous smoothing effect on the variables that you like to change, so that you get the best pricing strategy using the strong sides of both old and new of analytical world. So what Earnix has for you? Earnix integrated machine learning offers you now embedded our machine learning algorithms that you can build within the system. Our research team works on identifying which of the huge number of machine learning algorithms are the best fit for financial industry. So say for now we have the gradient boosting machine algorithm built in our system because we found that this is one of the most useful algorithms for banks and insurance. We also give our more advanced users other algorithm choices like random forest, XGBoost, and machine learning GLM family. By the end of the year, we plan to extend our embedded machine learning capabilities to other machine learning algorithms, and we also introduced the hybrid modeling. In future, we plan to embed more and more machine learning algorithms to our system and also extend the use cases of hybrid modeling to more and more cases. So altogether, this is Earnix integrated machine learning platform.
Thank you, Lucy. Now we're going to move on to our demo, which Yaron Nefesh, our research team leader, will present. Yaron?
Thank you. So before we dive into the concrete demo, I would like to share with you a common phrase in the industry. When you're fundraising, you're selling everyone an idea that you are doing artificial intelligence. When you're hiring, you're selling your optional employees that you are doing machine learning. But when you're implementing, you just use linear regression. People want to use machine learning, but they just don't, from several reasons. And in this concrete example, I'm going to show you how Earnix breaks it. In this demo, you will see that using machine learning within Earnix is not a black box anymore. It's easily visualized, integrated, and deployed. And I'm sure integrating machine learning within Earnix, it's the best simple way that will lead you to a success, receiving much better results in much shorter time. So let's talk about our case study. We are an insurance company, and we have our current pricing strategy for our new business customers in the auto insurance line of business. It could be MTPL or Casco, and we understood our customers are shopping around before they are closing a deal. So to improve our customer understanding, we would like to have some information of our premium relative to our main competitors and add this new information to improve our models and customer behavior understanding, and by that, upgrade our strategy. So we bought some data set from an aggregator that includes information of the quotes of 4 different main competitors, and we would like to develop new models to predict their offered prices to future quotes. We don't want to maintain too many models, and we want very flexible models to predict our competitor pricing strategy. So machine learning are very convenient and suitable solution for that. Once we finish developing those 4 machine learning models, we would like to embed them in our current project and update our customer behavior models and strategy. So let's move to Earnix and see how easy it is and simple to embed machine learning models. Great. So a pricing process has several stages, as can be seen on the left side of the software, starting via the data management, where we can visualize and handle the dataset, via the modeling stage, where we are replicating our business process and modeling the customer activity, until the pricing and monitoring stages to create and monitor our strategy. Since we already have our current strategy, we won't start from scratch. So we'll start from our modeling stage. In the modeling stage, we are going to focus on core parameters, which includes the parameters that probably each one of you already used and familiar to, like the origination demand, the actuarial cost, and others. And we're also going to use custom parameters where you can create and upload new models. So let's see how simple it is to integrate machine learning models. We have 2 options to do that. The first option is to use Earnix built-in functionality. In order to do that, we are going to move to a Create Model version window. In this window, we are able to choose any model that we have over here in the list. So it could be, for example, a GLM model, like logistic or linear model. It could be multinomial, we could use an imported data robot model. We can use the built-in functionality of GBM. So let's press it. Over here, once we press it, we have two tabs, the training data and the model parameters. In the training data, we are going to select the competitor dataset that we would like to predict. In the dependent column, which is our target, we are going to pick the premium. Again, because this is the variable that we are trying to predict. Over here, we are going to choose the explanatory one. So for example, I'm going to choose age, brand, pure cost, which is our actuarial cost. And you can select in the model parameter a lot of hyperparameters in order to tune your model. Right now, we are going to choose the default one with one adjustment. We are going to use number of folds of 2. So we will have some validation data set, and then we just press fit. Another option is to use is to import a module file that was built using an H2O. You can build it using Python, you can build it using R, Java, or any other software you like. So here it is. All you need to do is just import, upload the file that includes your module file. Once you press finish, that's it. You have it within Earnix. Once you upload a module file or you develop it by yourself, you can see several things in order to reveal the black box machine learning has. So for example, you can start with the model summary to understand what was included, what was the main parameters of your model. So for example, the premium, we try to predict the premium, so the distribution is a gamma one, okay? We had 500 trees in this GBM, the max depth was 10. So these are the main component of this model. Another thing that probably most of us are using is a comparison of the different metrics between our training dataset and a validation dataset. So we can see the R-square, for example, it's very high, almost 90%, and we can see we are not overfitting because it's more or less the same. Another important report is the variable importance. We can see over here and compare the variable that we use in our model. So for example, pure cost, which is actuarial cost, is ranked the highest, meaning it's got about 21% of importance in this model, while the age, for example, it's only 2%. We can visualize our model using any data set that we have. So for example, I use one of our data sets, and now we can visualize the results again in order to reveal this black box. So let's see the pure cost, which is again our most important variable. And as you can see over here, the effect, it's a strong effect as was expected from this variable. And we can zoom in, we can zoom out, we can do whatever we want, just like any other model or formula in Earnix. We can analyze the parameters. So for example, we can see that the average price of this competitor is around 21. So once we have within Earnix 4 different machine learning models over here, we can do a lot of things with them. Now we want, again, to embed it into our GLM model. So we can put them as they are, but we can do something more sophisticated than that. So for example, we could calculate the relative difference of our premium to the cheapest one. So let's calculate the cheapest one. So we can use, again, a built-in formula in Earnix, which is the minimum, that compares each one of our machine learning predictions and calculate the minimum value between them. We can use the rank, and again, a built-in function that compare our premium to all other premiums and gives us back our rank compared to the others. So now let's just add it to our GLM. So we have our current strategy, our current GLM, and now we want to embed those machine learning transformations that we just calculated. So let's do it. Let's first pick and create another variable, which is a dummy variable in case we are the cheapest. Let's add rank itself, and let's add also our premium compared to our competitors, and just fit. And we will see the results in a second. Great. So now we can compare, but just to mention, we just upload easily 4 models. We visualize the black box results very quickly. We simply combine those 500 trees dynamic formulas into another calculation, and now we embed them into a GLM model. So let's compare the results. And here it is. So we have over here on the left side of this report, you can see the transformation. So the only difference between those models, the GLM, the current GLM model, and the new one, which includes the machine learning, are those 3 transformations. If you compare the Somers D, the Gini, which give us some information about the goodness of fit of the model, so you can see the huge improvement from 28 to 49. Over here on the graph, you can see the real effect of these models that were embedded. So the old model, which depicted in the blue curve, is actually cannot understand the effect of being the cheapest, of being ranked number 1, and it's more or less flat all the way, while the actual value is actually over here, which the GLM that includes the machine learning can understand this effect. So he can understand the effect of being first, and the drop from going of being first to be the second and third and all the way down. We can, again, visualize it. We can have a single profile analysis just like in any other model. So let's see the effect of the premium, and let's zoom in over here. So again, take a look. See the flat curve of the regular GLM compared to the new one. And as you can see, this is a huge drop because we move from being the cheapest, again, rank as the first, to being the second. In order to find the optimal point in the pricing stage, we are able to use a grid search that enables us to look all over the range in order to find this optimal point. We can apply these models and compare the same thing on a test data set. So let's do it together. And again, we can compare the Somers D. More or less the same value, 49%, meaning we are not overfitting. Even that we are using 4 machine learning models with very high depth and number of trees, again, we are not overfitting. As you can see, everything that can be done using a GLM can be done as well when we are using machine learning model embedded in the GLM. No constraints and no adjustments. The same thing, if we will move to the pricing stage, we can create new pricing stage. Let's change it to be with machine learning. This is the base case. And as you can see, we change just a second. Let's change it to be the new machine learning model. Here it is. So again, we are going to calculate a base case scenario using this machine learning model. Just as I did over here, you can do in the price and execution stage. And you can actually deploy fast and quickly to the market a new strategy that's using machine learning models. Before we sum up, I would like to emphasize one last time the importance of customer understanding. In order to do that, I would like us to look on 2 optimization scenarios. The goal of each one of them is to increase share in the market by 10% and to reach 2.7%. The first report on the left is an optimization with the assumption that the current GLM is the right one, while the one on the right is using the new GLM with machine learning. So it can be easily seen both scenarios reach the same goal. But what was the cost of reaching that goal? The graph on the bottom visualizes the new strategy, which depicts in yellow, compared to the old one, which depicts in blue. As can be seen, the goal of retention was reached. But in order to reach that, in the old one, in the blue one, we need to act dramatically. We need to increase prices dramatically, almost to all of our customers, to the end of our range of about 10%, while the new one is much more sophisticated and balanced. So prices distribution is all around our range. And in the bottom line, if we compare the expected profit, it was improved in the new one. So I just want to say a few more things. So I'm sure using machine learning is beneficial, as can be seen over here, for each one of us and can improve our results. So I advise you to go and implement machine learning model in your current projects. And by that, you will increase your performance and your customer understanding. You'll have better models, better insights, better results in much shorter time, and you even enjoy your work much more. Thank you.
Thank you, Yaron. And thank you, Lucy. So to briefly summarize what we presented today, first, we see that machine learning is being used widely to improve analytical modeling, speed, and accuracy. Toward that end, Earnix is working with organizations at all levels of maturity. These organizations are able to develop and deploy these models quickly. With the help of Earnix software and professional services, users are able to build models for themselves, eliminating the black box problem that many are experiencing. And lastly, we are combining classical models with machine learning to create hybrid models that get the best of both for truly best-of-breed modeling. Next, if you'd like more information about Earnix machine learning software and services, please visit our website. You'll see on your screen the URL for the page that has our product information, as well as our thought leadership reports and research. If you have any questions for either Lucy or Yaron, please contact them through their email, which is shown on the screen. And if you'd like a more in-depth demo or speak to one of our sales representatives, please contact me and I will arrange for a follow-up call. So that's the end of this webinar. Thank you very much for joining us today, and have a very good rest of the day.